ever think about, like, how do we teach computers to see like we do? Not just, show a 3D model that's already made, but to actually understand depth
Right.
from a flat image. Like, how is that even possible?
Yeah.
It's really incredible when you think about it.
Yeah.
Something that's, been worked on for decades and decades.
Totally.
And today, we're going to kind of do a deep dive on that.
Yeah, absolutely. And it's led to some pretty amazing breakthroughs, I would say, even in like our everyday lives,
Oh, for sure.
which we'll get into.
Yeah, this is like in your pocket right now, this technology.
It is.
We're talking about multiple view geometry,
Right.
which is kind of like the engine behind how computers can actually start to extract three-dimensional information from just two-dimensional pictures, like the ones in your phone.
Exactly.
And to help us on this little journey today, we're going to be referencing multiple view geometry in computer vision.
Right.
By Hartley and Zisserman.
Hartley and Zisserman, yeah, kind of I mean, everybody considers it the Bible.
Oh yeah.
In this.
It's a dense read.
It is dense, but
It's
but like worth it.
yeah, and it's filled with all these like aha moments.
For sure.
Where you're like, I see the world differently now.
Yeah, you understand how these things are working under the hood, and all of a sudden, like these things that seemed like magic before, you're like, oh, okay.
Yeah.
That's how that works.
Like I can see how like math
Totally.
could arrive at that conclusion.
Yeah, and I think the coolest thing about it is you don't really need to get into the weeds too much to appreciate sort of what it's doing, because it all builds like anything from, the fundamentals. And so we start this book and they're talking about, okay, how a single view, how a single image relates to the 3D world. We can't just throw like complex 3D models at a computer. We got to start with like, okay, here's a two-dimensional, representation of something.
Right.
How does that relate at all to the three-dimensional world,
It's kind of how like artists have been using perspective
For sure.
for like centuries, right?
Totally.
Where it's like you can have depth
Totally.
on a flat canvas.
Yeah. And the Renaissance painters were doing this without even really, they were figuring it out, they didn't, but, so yeah, we start with that. And then, one of the concepts I think is really interesting is this idea of ideal points and the line at infinity.
Okay.
Now, I know those sound a little abstract.
Yeah, they sound a little scary.
A little bit, yeah.
Yeah.
They sound like you're going to be like launched into a black hole or something.
Right, exactly.
But imagine like just standing on a long straight road.
Okay.
And you see how the edges of the road, although they're parallel,
Right.
in reality,
Yeah.
they seem to converge
Right.
at a point in the distance.
Yeah.
Yeah. That point where they kind of seem to meet, that's what we would call an ideal point. And so projective geometry kind of uses this idea to represent how parallel lines, even though they never technically meet in 3D,
Right.
they appear to meet in images.
Right, yeah.
Yeah, and so we need some way to kind of translate between those two.
So it's like a mathematical trick almost.
Exactly. It's a
Would
way
be like, how do we
to represent it, yeah.
how do we connect this?
And that's really important because once we can relate the geometry of the real world to the geometry of these images, that's when we can start to actually pull out three-dimensional information from those flat pictures.
I see.
And that's really where multiple views come in. So and the book lays this out really well. It goes, it's like a roadmap. It starts with like, how do you analyze a single image?
Right.
Right. How do you analyze two images, then three images, then n images,
Right.
And it kind of builds up in complexity as you go, which makes sense.
Yeah, okay, so walk me through that. So
Yeah.
how does going from one image to two images all of a sudden unlock that third dimension?
So imagine taking two pictures
Okay.
of an object from slightly different positions.
Okay.
Now, if we can identify matching points in those two different pictures,
Okay.
we can actually use those points to calculate depth. It's kind of like, have you ever heard of triangulation? It's like how surveyors measure distances.
Okay.
You have each camera becomes a viewpoint, and then those corresponding points in the images become our kind of reference points.
I gotcha.
So as long as you know where the cameras are
Yeah.
and how those points line up in the image, all of a sudden you have a way of measuring things in 3D.
So cool. Okay.
Yeah, and that leads to another really important concept, which the book talks about, which is camera calibration.
Okay.
So this is all about basically understanding the kind of the eye, so to speak, that captured the image in the first place.
Right.
And there's a really interesting example that the book uses involving like a distorted circle. You remember that?
Yeah, I remember that. I was like, oh, wonky circle. Okay, what's up with that?
Yeah. So if you have like a circle and it's distorted in an image, that can tell you a lot about the lens itself, like the focal length, the angle of view, things like that. It's almost like, you know how like fingerprints can be used to identify which camera captured? So it's kind of like that. It's like we're analyzing these distortions.
So it's not even just like what the camera is seeing.
Exactly.
It's also about the camera itself.
It's understanding the camera's own perspective in a way.
Right, okay.
And so this calibration process, it's basically like figuring out what are those unique characteristics of this camera.
Right.
And that's essential for doing accurate 3D reconstruction, because it's kind of like, imagine trying to, use a ruler to measure something, but you don't know like what the markings on the ruler actually mean.
Right, yeah.
You need to know it's got to be calibrated.
Exactly. You need to calibrate. And here's where it gets even more interesting. So they talk about in the book how if a camera is rotating around a fixed point, a lot of the calculations become a lot simpler.
Really?
It's like you found a shortcut.
So why is that? Why is that shortcut so important?
It's huge. And I'll tell you why. That is the basis for how we create those like seamless 360 panoramas that we all love,
Right.
Because if you know the camera is just rotating around a fixed point, then stitching all those images together becomes a lot easier. It's almost like if you're doing a puzzle,
right,
and the pieces fit together perfectly. There's no forcing it. You know what I mean?
Yeah, so that mind-blowing panorama I took on vacation, that was all thanks to multiple view geometry.
Multiple view geometry.
Yeah.
That's incredible.
It is pretty cool.
Okay, but hold on. So in the real world, right?
Yeah.
Like lenses aren't perfect.
Yeah.
Right? Like lighting changes.
Absolutely.
There's all these like imperfections.
And that's where the real cleverness of these algorithms comes in, is how do you account for that messiness?
Yeah.
How do you account for the fact that...
How do you deal with that?
Exactly. Yeah, and so that's where this idea of robust estimation comes in.
Okay.
It's basically you have all these different algorithms, and they're designed to handle real-world imperfections. It's like, imagine you have a bunch of measurements, but some of them are way off.
Right.
Like robust estimation is like having a techparium who can kind of sift through that data and be like, okay, these are the ones that actually matter.
Right, yeah.
It's almost like, those crime dramas where they magically enhance the grainy security footage?
Right, exactly. It's like enhancing.
It's kind of like that. You're like, okay, we know there's information in here, but how do we actually extract the meaningful information?
Right.
And just like in those shows, there's not just one, magic solution.
Right.
Different detectives might have different techniques.
Right.
And similarly, in multiple view geometry, you have all these different algorithms, and they're all kind of tailored to handle...
So it's about picking the right one.
Exactly.
For the job.
For the specific problem you're trying to solve.
Right, okay.
It's about having the right tools and knowing which one to use when.
So we've got this like powerful toolbox of algorithms now.
Right.
Each one designed to kind of tackle these like very specific challenges.
Right.
In reconstructing this 3D world from 2D images, right?
Yeah.
But before we like jump into like all the cool applications of this, right?
Yeah.
Like how do all these different pieces fit together? Like what's a common thread?
That's a great question. I think the common thread is that they all kind of stem from that same foundation of projective geometry that we were talking about. So even though, each algorithm might have its own kind of quirks and complexities, they're all at their core trying to solve that same fundamental puzzle of, how do you go from 2D to 3D?
Yeah. It's almost like, imagine you have, all these different languages.
Okay.
But they're all expressing the same underlying ideas.
Yeah. And it's amazing that we can even do that. It's like we have this limited data.
Totally.
And we're like, we can extrapolate all this other information.
Yeah. The fact that it even works at all is kind of mind-blowing.
Totally. The implications are huge, right? Like if you think about like robotics.
Huge. Robotics, I mean, you think about a robot, it needs to be able to perceive its environment, it needs to understand
where things are.
The position of things.
Yeah.
And if it's navigating a space, it needs to be able to do that without bumping into everything.
Right. And not just robots, right? Like, what about, you mentioned earlier, like medical imaging? Oh my gosh.
Yeah.
Like, how is this being used in healthcare?
Yeah, I mean, this is transforming how doctors diagnose and treat patients.
Uh-huh.
Because now, imagine, like, you can take a series of 2D scans
Right.
and then create a full 3D model
Oh.
of, a patient's organs, for example.
Oh, right.
And so, that allows surgeons to plan these really intricate procedures
Oh, wow.
with incredible precision.
So it's like they can practice almost.
It's like practicing, yeah. It's
Yeah.
like they can, and that obviously minimizes risk, improves outcome.
Yeah.
All these things.
It's amazing to think that, like, these very simple, I mean, they're not simple, but, like,
Wow.
these kind of, like, core concepts, like ideal points and stuff,
The fundamentals.
lead to these huge,
They really do.
like, ramifications.
Yeah.
And what's even more interesting, I think, is that it's not just about reconstructing what's already there.
Right.
We can actually use this technology to create
Okay.
entirely new worlds, like virtual environments.
Right.
That feel incredibly real.
You're talking about like VR, AR, all that stuff.
Virtual reality, augmented reality, all of it. And it's interesting because, there's this blurring of the lines now between the digital and the physical.
For sure, yeah. It's like every day they're getting closer and closer.
And multiple view geometry is like right at the forefront of that because, the more accurately we can reconstruct the real world, the more immersive and realistic those virtual experiences become.
Right. It's like, I can imagine like architects designing a building, and then you can go in,
walk through it,
and actually, be in this space.
before it's even built.
That's wild.
It's like stepping inside the blueprint, know?
Totally. But one thing that struck me, like when I was reading like Hartley and Zisserman, they kept on talking about uncertainty.
Right.
And it's like, even with all these amazing algorithms, there's still this margin of error, right?
Always. I think that's such an important point because it's easy to get caught up in the kind of the excitement of it all and forget that, we're dealing with...
The real world's messy.
The real world is messy. Sensors have limitations,
Right.
Every measurement has some degree of uncertainty.
So it's not just about, like, finding the answer. It's like...
It's about understanding. There's a range of possibilities. Exactly.
Okay.
And so we use, statistical models, probability, to kind of represent that uncertainty, to say, okay, we're fairly confident that, this 3D model is accurate.
Right.
But there's a chance that, we could be off by a little bit.
Right. It's about being honest about what the technology
exactly.
can do.
And especially as these technologies become more powerful, more integrated into our lives.
Right.
I think that's a conversation we need to be having more and more.
Totally.
Not just what it can do, but
the limitations. The
potential pitfalls.
For sure.
Yeah.
Like we're giving computers like a whole new sense,
Totally.
a way to like actually perceive the world.
Yeah.
In ways that like we never could have imagined before.
In ways that we take for granted, I think.
Yeah.
Like we look at the world and we see in 3D, but getting a computer to do that, it's not trivial.
No, not at all. And it all goes back to like these fundamental concepts that we were, talking about from like Hartley and Zisserman, right?
Mm-hmm.
Like this idea that you can like take multiple views and like with the right
mathematical tools.
Mathematical tools. Extract all this information.
You can unlock that third dimension.
Yeah.
That isn't obvious.
That's not obvious.
From just a single image.
From a single image. Yeah, that's incredible.
Yeah.
It's like all that complexity
it is.
Hidden within like,
in these everyday photos,
photos that I take, like without even a second thought.
Right, exactly.
It's like, wow, there's a lot going on in there.
It's wild.
So for our like listeners out there who aren't like computer vision experts, right?
Sure.
Like what's the key takeaway? Like why should we care? Why is multiple view geometry?
That's the question, right? Why should anybody care about this? I think the easiest way to think about it is this is what allows computers to see depth.
Okay.
To understand spatial relationships.
Okay.
In the same way that we do.
Okay.
And so it's the foundation for all of these technologies that we use every day that maybe we don't even think about.
Okay, like what? Give me some examples.
Like augmented reality.
Okay.
Right. Like, all those apps where you can hold your phone up and it like overlays, digital objects onto the real world.
Right, yeah.
Well, if your phone can't accurately perceive the 3D space around you,
Right.
those virtual objects aren't going to look like they belong there.
Right, they're just going to look like at a place.
It's going to be like a bad Photoshop job. Right.
Yeah, exactly.
But when multiple view geometry is applied correctly, it's seamless. The virtual blends with the real in this really like natural, believable way.
That's amazing.
Isn't it?
It's like where does the digital begin and the real end, right?
Totally. And it goes beyond just, our phones and these,
What about other fields?
I mean, the possibilities are really endless. Think about self-driving cars, being like to navigate these complex intersections, avoiding obstacles, avoiding pedestrians. You need that accurate.
Right. You need to know where things are in relation to.
You need to know where things are. Architects,
Yeah.
being able to create these virtual walkthroughs of buildings before a single brick has even been laid.
That's wild.
These are just, these are just glimpses.
It's like we're just scratching the surface here.
Just scratching the surface of what's possible.
Yeah.
As these algorithms get more sophisticated, and frankly, as our understanding of multiple view geometry itself deepens,
Right.
we're going to see even more groundbreaking applications, I think.
So next time I'm scrolling through photos on my phone, I'm gonna see them in a whole new light. Literally.
Yeah.
Like each picture's like a little treasure trove.
It is.
Of 3D information.
Just waiting to be unlocked. Yeah.
Just waiting to be unlocked.
That's a great way to put it.
Awesome. Well, hey, I think that's about all the time we have for today. But
I had fun.
Yeah, me too. This was awesome. And I think that's kind of what we were hoping to do today, was to kind of open your eyes to this idea that, like, there's these hidden dimensions all around us, and multiple view geometry is this really powerful tool for kind of like understanding,
blocking that information.
Yeah. And interacting with the world.
I think that's a good note to end on.
Awesome. Well, hey, thanks for joining us on this deep dive into the fascinating world of multiple view geometry.